Hello everyone. Today we are going to learn VaryCurve method. Okay, in VaryCurve method, what we do? Suppose we have to find out the value of 1 by x, which is less than x. Okay, so you have to find the value of x so that it is satisfying. Okay, for all x, we have to find the value of all the x so that it is going to satisfy this inequality. What does it mean? I'll take here 1 over x. Okay, so suppose 1 over x less than 1, I'll take x equal to 1 over 5. Okay, and I'll put here, so 1 by 5 less than 1, which is going to be equal to 5 less than 1. Is it satisfying? No, it is not satisfying. Okay, similarly, if I'll take x equal to 2, so you can see that 1 by 2 less than 1. Okay, and it is true. So we are going to learn how to find out. Okay, so how many values are going to satisfy these. Okay, basically we have to find an interval. So to find out that interval, you have to find out, we should learn the VaryCurve method. Suppose x minus 1 less than 0, so x is going to less than 1. So here you can see that if you take all the values of x minus infinity to less than 1, okay, so it is going to satisfy. Take any value between minus infinity to 1, it is going to satisfy, right? So similarly, if you have different x, 2x minus 3x plus x square minus plus 5, okay, less than 0, how do you find out these value? Okay, means we have to find out the value of x so that it is going to satisfy, means the inequality is going to satisfy. So to learn that, we have to learn VaryCurve method. So in VaryCurve method, what we do? So let me write down the VaryCurve method first. There are 3 rule. Okay, so basically there are 3 steps to use it. So first of all, what we do? We plotted only odd power of x. So let me write the rule, and using this rule, we'll solve some question and it would be clear to you. So plotted only odd power of x. Okay, and second, make the coefficient of x positive. Okay, and third, starting number line, taking the sign outside the expression. Okay, outside the expression, from right to left. Okay, from right to left. From right to left. And alternatively, it is important. No. So there are 3 steps. It use VaryCurve method to find out the solution. First, what we have to plot only for odd power of x. Okay, it is odd power of x. Make the coefficient of x positive, and starting number line, taking the sign outside the expression from right to left alternatively. Okay, what does it mean? I'll consider an example. Okay, let me take a simple example. 1 over x minus 1 less than 0. Okay, so this is the example and we will solve. So to solve it using VaryCurve method, we have to find out the values of the x. So what we do? So let me simplify this expression. 1 minus x over x less than 0. We can write down, take negative sign, x minus 1 over x less than 0. Okay, now after that we have to see, you can see x minus 1 to the power 1. So these all are the odd power of x, right? It means x minus 1 is it power 1, x to power 1. Okay, so we have to consider only expression, like here suppose we have x square into x minus 1. Okay, and x, so you don't have to consider x square. Okay, now x minus 1 over x. So x minus 1 equal to 0, x equal to 1, and x equal to 0, x. So here it is in a denominator. Okay, so it is in a denominator, you don't have to consider, means it should not be equal to 0, x not is equal to 0, but you have to equate it. Here is it non-zero, although it is non-zero, but here on the number line we'll draw it. Okay, on the number line what we'll do, we'll draw it. So this is our number line, and you can see that what we have here we have 0 and here we have 1. And what is the sign of this expression? The sign of this expression is the entire expression. The sign of the entire expression is what? The sign of the entire expression is negative. So we'll come here, we'll write down negative, positive and negative. And here you don't have to include this point, right? You don't have to include 0. So what does it mean? It means, it is saying that if you use this number line, it is saying that all the numbers, okay, all the numbers which are greater than 1, it gives you a positive value. Means if you put all the numbers which are greater than 1 in this expression, it give you a negative number. So it give you negative number, and means entire expression, the value of the entire expression is going to be negative. And if you take the value between 0 and 1, it gives you a negative value, positive, sorry, here since there is a negative sign already, so it gives you a positive value. But if you take all the numbers which is less than 0, it also give you a negative value. So let me verify. So here what we do, consider any number x equal to suppose 2. If you put here negative 2 minus 1 over 2, which is equal to minus 1 over 2, you can see it is negative. If you take any number which is less than 0, so put here my negative 3 minus 1 over minus 3, which is equal to minus 4 over 3. Okay, you can see negative. But if you take any number 0 and 1, take 1 by 2. So it is going to be 1 by 2 minus 1. So minus of minus 1 by 2 over 1 by 2, right, is equal to 1. So it gives you a positive value. Here you can see that what we need to find out, we have to find out, okay, all the values of x which gives you a negative value. So means x must belongs to minus infinity to 0 union 1 to infinity. Okay, and this is the solution using Varicab method. So we find all the values of x for which this given equality is going to satisfy. Okay, now let me take another example. So here we have x minus 1 into x minus 2 divided by 2x plus 1 into 2x plus 3. Okay, so this is an example and you have to find out the solution. Okay, put here inequality sign also, and you have to find out the solution of this. How do you find out the solution? First of all, we have to see all the odd powers. Okay, x minus 1 is odd, has exponent as 1, x minus 2 has exponent as 1, 2x plus 1 exponent 1, 2x plus 3 exponent 1. Okay, now so numerator x minus 1 should equal to 0, x minus 2 equal to 0, so x equal to 1 and x equal to 2. And also here we have to do 2x plus 1 should not be equal to 0 and 2x plus 3 should not equal to 0, since it is in a denominator, so like p of x over q of x. Okay, it is a rational function. You know that any rational function is going to define if and only if qx not equal to 0. Therefore that's why we consider 2x plus 1 not equal to 0 and 2x plus 3 not equal to 0. So x is going to not equal to minus 1 over 2 and x is not equal to minus 3 over 2. Now on the number line we'll draw all the points. Okay, so here, so what we'll do, so we have one second, so we have this number line. Now I will put all the so the minimum is negative 3 by 2, right? So here negative 3 by 2 and negative minus 1 by 2 and 1 and 2. After that, what we'll do, we'll see what is the sign of this expression. Here I'll see the sign of the expression is positive, right? So we'll come positive, negative, positive, negative, and positive. Okay, this is the third step of the definition. Okay, here you can see that in definition, a starting number line taking the sign outside the expression from right to left alternatively. That's why I'm taking there. So plus, positive, negative, positive, negative, and positive. And you can see that we have to find out what? We have to consider all the values, okay, which is less than equal to 0. So it gives you this and this, right? And you can see that here we don't have to include these 2 points, since if you include these 2 points, it gives you something by 0 which is undefined, right? Means here if I consider q of x, and for these two value it is going to be 0, and it is in a denominator, so it give you undefined value. That's why we don't have to consider these 2 points now. So the value x should be belongs to minus 3 by 2 to minus 1 by 2 and union 1 to 2. Here we have to take 1 and 2 also, since it is in a denominator, numerator, sorry, it is in a numerator, and you can see that here we have inequality sign, right? That's why. I think you understood this question now. So we have another question. And before moving, let me define modulus function. What is called modulus function? Okay. So modulus function. So in modulus function, what we do? We have y equal to mod of x. Okay, what does it mean? It is saying that y equal to mod of x. We have x when x is greater than 0 and negative x when x is less than 0. What does it mean? If I say y equal to 2, then it's give you 2, since 2 is a positive. Okay, directly I'll put. Okay, if I consider y equal to negative 2, you can see that here I have to write down negative of negative 2, since minus 2 is less than 0. Okay, so it give you 2, y equal to 2. So it will give you always positive value, but you should know how to get this value. Okay, now, so if I talk about, so y equal to mod of x, okay, you can see that its domain is going to be equal to what? Domain is going to be x, and which is minus infinity to infinity, means it you can take any real number, okay, and it will give you some value, right? Y equal to mod of a, where a belongs to r, it gives you a absolute value of it. So basically when a when a is positive, and negative a when a is less than 0. Okay, now and what about range? A range of this y equal to mod of x is going to be equal to, a range of y equal to mod of x is going to be equal to what? A range. So to find out the range, I can draw the graph. Okay, so you can see that it is y equal to mod of x. Okay, so here x and x dash, here y dash and y, and this is y equal to mod of x, and this is origin 0 0. So you can see that all the values of the y equal to mod x is greater than equal to 0, right? So range is going to be equal to, range is going to be equal to what? So our range is going to be equal to 0 to infinity, including 0, because at 0, if you take y equal to 0, mod of 0, it gives you 0, right? Now let me take an example. Y equal to mod of x minus 1. Okay, so how do you define y equal to mod of x? So here I can say y equal to mod of x is going to be equal to x minus 1 when x minus 1 is greater than 0, and negative of x minus 1 when x minus 1 is less than 0. It means that we have x minus 1 when x is greater than equal to 1, greater than equal to 1, and x minus x plus 1 when x is less than 1. Okay, this is the solution. And if you would like to draw the graph of it, so what we can do, it is easy to draw. So I'm not going to discuss, but just I am going to explain how to do it. So here what we do, draw x-axis, y-axis, and here you can see that it is going to be equal to what? This is the value of y equal to mod of x, right? And here it is shifted x minus 1. So x minus 1 means it is going to shift this side, right? So this is going to be equal to y equal to x minus 1. So x minus 1 is going to be this, okay, and y equal to minus x plus 1. So y equal to minus x plus 1. So here we have, okay, it is going to be x less than 1. So y equal to x minus 1, this, and you can see that this is the graph of y equal to x minus 1, and this is the this is the graph of x minus x plus 1. Leave it now, it will create a confusion now. So y equal to x minus 1, x greater than equal to 1, and minus x plus 1 when x is less than 1. Now let me define and take another question. Y equal to mod of x minus 1 into x minus 2. Okay, so we would like to draw the we would like to find out the solution. Basically we have to define this modulus function. So what we do, so x minus 1 and x minus 2, we can write down x minus 1 into x minus 2 when x minus 1 into x minus 2 is greater than equal to 0, and x minus 1 negative of x minus 1 into x minus 2 when x minus 1 into x minus 2 is less than equal to 0, right? So simplified, x minus 1 into x minus 2 is going to be equal to x square minus 3x plus 2, and here negative of it, right? So minus x square plus 3x minus 2. So we have to x minus 1 and x minus 2. So draw a number line, so 1 and 2. Okay, so we have to take all the positive value, right? So positive, negative, and positive. Since I wrote here positive, since the sign of this expression is positive, that's why positive, negative, positive, right? And 1 and 2. So we have to consider all the values. So here you can see that it is positive when x is less than 1 and x is greater than 2, means x should be less than equal to 1, and union, you can say union and union x is greater than equal to 2. So we can also write down x belongs to minus infinity to 1 and union 2 to infinity. This is the, now for this one we have to consider only negative value, right? 2 and 1. So here positive, negative, positive means we have to consider only value which lie between 0 and 1, but here I don't have to consider equality sign. So it means 1 x less than 2, right? It means x belongs to close open interval 1 to 2. I'm not taking the close sign here, since in the here we don't have equality. Okay, here we don't have equality, here we don't have equality, that's why. Now we are going to learn some more concept using the modulus. So here let me write down all the property. So here x square, if I write down the mod of x square, okay, mod of x square is going to be equal to x square. Okay, now if I'll take mod of x less than y, and where a is positive, Okay, if you consider a is positive, right, where a is positive, if you consider a is positive, then it is going to be equal to what? It is going to be equal to minus a less than x less than a. Okay, now if you take any number okay, a mod of x is always greater than a when a is negative. Okay, like if you take any number modulus and it is going to be greater than minus 2, because it gives you always positive value and it is negative, so it is always positive, so it is going to satisfy, right? Now the fourth one, mod of x is greater than a when a is positive. Okay, so in this case we have x greater than a and x less than minus a. We will define it now. In the fifth one, mod of x is less than 1 when a is negative. So you can see that mod of x can be negative, can be less than negative, no. So in such case we don't have any solution, so we write down no solution. Okay, now sixth one is a less than mod of x less than b. So in this case, when a is positive and when x is positive, then we have x less than b. But when we have x as a negative, so what we write down? A less than minus x less than b, and we have to multiply, so with a negative sign, so minus b less than x less than minus a. So this is going to be the property. And the next property is mod of a plus mod of b equal to mod of a plus b, where a and b is positive, greater than equal to 0. Means if we have this condition, it means that it is going to satisfy this condition. Got it? If you have mod of a plus mod of b equal to mod of a minus b, it means that we have a minus b is less than 0. Okay, now so we can prove it also. Whatever the property I wrote, we can prove it. So here you can see that first we considered mod of x. Okay, so mod of x when x greater than 0 minus x when x less than 0. Okay, so here x is greater than 0 means x square equal to x square. Okay, so x less than x square equal to x square. So you can see that mod of x square equal to x square. That's what we wrote. Okay, now the second we have to prove mod of x less than a. So what we can do a square. Mod of x square is less than a square, so x square minus a square is less than 0, and x minus a into x plus a less than 0, and we can see that here. So we have minus a and plus a, so positive, negative, positive, means x should be greater than minus a and less than minus a, right? So this is the solution. Now when we have mod of x greater than a, okay, so here the same way we have to do the square, and if you do the square, x square minus a square greater than 0, okay, x minus a into x plus a, and here the same result. So but here we have to consider positive value, right? So here minus a and a, so plus minus plus, right? So here means x should be less than, x should be greater than a, and x should be less than minus a, right? Less than minus a. This is the property. Now the extra I think that another formula we have proved there. So we have mod of a is less than mod of x less than b. So a is less than x less than b when x is positive, right? There is no doubt. And when it is negative, so a less than minus x less than b, right? So here we have negative sign, so we know that when we multiply with negative sign, the inequality is going to be changed. Okay, so multiply negative sign, so it is going to be equal to minus b less than x less than minus a. And there are two property I wrote down: mod of a plus mod of b equal to mod of a plus b. Then we have a into b is greater than 0, right? So we have to prove it. So how do we prove it? So you can see that we'll take the square of both sides. So we'll obtain here mod of a square plus mod of b square, and which is equal to 2 of mod of a into mod of b, which is equal to a square plus b square plus 2ab, right? And here what we can do, you can see that these value are equal. So 2 mod of a into mod of b equal to 2ab, which is equal to mod of a mod of b equal to a into b. You can see that here what we have. So mod of ab is equal to ab. I can write down ab equal to ab. So what does it mean? It means that ab is positive, right? Since it is never going to be 0 and it is equal to ab, so it means that ab has to be positive. Okay. Similarly, you can prove for mod of a plus b. When we have mod of a plus mod of b equal to mod of a minus b, then mod of a into mod of b equal to negative ab, and it means that ab has to be less than 0. Okay. So here equality sign. Now, so we have learned. Now using this property, you will solve some question. Okay. So the first question we have y equal to mod of x minus 1 divided by mod of x minus 2 greater than equal to 0. Okay. So what we'll do, we'll consider let y equal to mod of x. Okay. So when we consider y equal to mod of x, yeah, here I don't have to, sorry. So basically here mod of x, we have mod of x minus 1 divided by mod of x minus 2 greater than equal to 0. Okay, and we have to find the solution. So what we need to do, what we'll do, so let me consider here y equal to mod of x. So when we consider y equal to mod of x, this inequality is going to be y minus 1 over y minus 2 greater than equal to 0, right? And we know how to find the solution. So we can do using, so here we'll draw a number line, right? And then so y minus 1 equal to 0 and y minus 2 equal to 0 we have to put. So 2 and 1 will get. So what is the expression here? We have to exclude 2, positive, negative, positive, means we have to consider all the positive value only, means y has to be less than equal to 1 and y has to be greater than 2. Here I don't have to put equal sign. Got it? Now, so what we have, x, so y equal to mod of x we consider. So y x mod of x should be less than 1 and mod of y. Okay, so here I don't have to use and, here I can say yeah. Okay, because union, because it is going to define for the both the values, right? So and, so here I can write yeah, y is greater than 2, right? And so sorry, here I have to put mod of x. So mod of x is greater than 2. So x is less than mod of x is less than equal to 1. It means minus 1 less than x less than equal to 1, and mod of x means x is greater than 2, x is greater than 2 and x is less than minus 2, right? So what are the solution? So yeah and yeah. So it means that x should be belongs to, you can see, minus infinity to minus 2, right? Here I don't have to put equal sign, minus infinity to minus 2 union minus 1 to 1, right, with close interval, and union 2 to infinity. Okay, so this is going to be the required solution for the given question. So means the solution of this expression, the solution of this inequality is going to be equal to what? This is the required solution. Got it? Now the last question I am going to discuss. Here I have a problem. It is good problem. So mod of x square plus 3x plus x square minus 2 is greater than equal to 0, and you have to find the solution. So how do you find out the solution of this expression, this inequality? So here I don't so what we'll do, first of all we have to define this one. Okay, so what we'll do, x square plus 3x, mod of x square plus 3x is here, x square plus mod of x square plus 3x. It means x square plus 3x when x square plus 3x is greater than 0, and negative of x square plus 3x when x square plus 3x is less than 0. Okay, so here we have two cases. So what we can do in the case first, okay, in case first we'll consider it. Okay, so we can also write down it as a x into x plus 3 is greater than 0, right, greater than equal to 0. So if you consider here 1 and 3, so positive, negative and positive, and you have to consider only positive value, right? So it means that the value is going to be equal to what? Oh sorry, here x plus 3 I should write down negative 3 and 0. Okay, x equal to 0. So if you do it, so positive, negative and positive means x has to be less than equal to minus 3, yeah, x has to be greater than 0. So this is the condition, right, and equality sign. Now using this, so we have to consider, so when we consider this case, in this case it is positive, so we have x square plus 3x plus x square minus 2 is greater than 0, right? So 2x square plus 3x minus 2 is greater than equal to 0. Now so you can simplify it, you'll obtain 2x square plus 4x plus x, minus x here, minus x, and minus 2 is greater than equal to 0. So 2x take common, so x plus 2, take minus 1 common, x plus 2 greater than equal to 0. So 2x minus 1 into x plus 2 is greater than equal to 0, right? So here we have what? So we'll draw it. So on the number line we'll draw it. So what is saying it basically, so here, and draw another line here also. So here we have x equal 2x minus 1 equal to 0, 2x minus 1 equal to 0, and x plus 2 equal to 0. So x equal to minus 2 and 2x equal to 1 over 2. So here I'll write down minus 2 and here 1 by 2. So we have to consider positive, negative, positive means all the values which is greater than 0. So this. Now before that we have here, there is another constant, right? So here minus 3 is there, okay, and a 0 is there. So it is saying that you have to consider all the value which is greater than 0 and less than minus 3, right? And it is saying that you have to consider all the values which is less than minus 2 and greater than 1 by 2, right? And according to this, it is saying we have to consider all the values which is greater than 0 and all the values which is greater than minus 3. So we what we can do, we have to consider only all the common values. So common values is going to be what? So all the values of x which is greater than which all the values of x which is lies between minus infinity to minus 3, a union 1 by 2 to infinity. You can see that if you take any number between minus 3 to minus 2, it is not going to satisfy. Although it is going to satisfy, but it is not going to satisfy, since it is saying that you have to consider all the values which is less than minus 3. Okay, so what is common? We have only these value, right, which is greater than minus 3, because in this case you have these are the solution, and also in this case, so we have to consider all the value which is common. So in this case you have these as a solution. Here we have to put equal sign, close interval. Okay, since there is inequality sign, and also at -3, and so this is going to be the required solution in the first case. Now you have to consider second case also. So in second case, what we have in the second case, basically you can see, so we have to consider here less than 0, so -3 to 0, right? Means -3 less than x less than 0. Okay, in this case, and we have this expression as a negative, right? It gives we have it as a negative with a negative sign. Now, so we can do negative of x square plus 3x plus x square minus 2 greater than or equal to 0. So here negative x square and negative 3x and plus x square minus 2 is greater than 0. Now cancel. So we have minus 3x minus 2 greater than or equal to 0. Take 3x minus 2 and greater than 0. Sorry, 3x plus 2. So here I can draw the number line. So here we have minus 2 by 3. So negative and positive, right? And here according to this what we have, -3 to 0, -3 and 0, right? So we have to take only common values.